Hello. So today we're going to be working with volume of spheres. And when we're looking for the volume of spheres, we're going to use this formula where volume is 4/3 pi times radius cubed. We know that a sphere doesn't have a flat base, but if we were to slice it directly in half, we do get a circular shape. And so we're going to call that the base just because this is what we're going to be focused on for the moment. It has a radius, or it could have a diameter. The area of a circle is pi times radius squared. And I'm going to show you how we come up with that. Alright, so we have a sphere is a three-dimensional figure with all points the same distance from the center. The radius of a sphere is the distance from a center to any point on the sphere. So no matter where I have it going out, it's going to be the same distance from the center. It doesn't matter which one it is. Okay. You have seen that a cone fills 1/3 of a cylinder. That is the same radius and height as the cylinder. And if we were to do a similar experiment with a sphere, if we put a sphere or cut a sphere out of a cylinder, we would notice that the radius is the same, and that the distance from the center to the top of the cylinder and from the center to the bottom of the cylinder, that is the height. So that would be our 2r. We're going to compare. So we have the cylinder formula is pi r squared times the height of the cylinder. The cone was 1/3 times pi times r squared times height of the cone. And then with the sphere, we have 2/3 times pi times radius squared times the height of the sphere. Well, we just said that the height of the sphere is 2r, so we're going to replace the h with 2r. Now, if I were to take and simplify this, I can move this 2 over here in the front so that I can get my numbers together and my radii together. So if I put a 1 under the 2, I can just multiply straight across. So I have 2 times 2, that is 4. 1 times 3 is 3. Times pi, I only have one of those. But then I have these r's. And remember, when I have the same base, I'm just adding my exponents. So 2 plus 1 would be r cubed. And that's where we get our formula, 4/3 pi r cubed. So we're going to use this information. We're going to find the volume of each sphere, and they want us to round them to the nearest tenth if necessary. So we know that this has a radius of 2.1, and in my formula I have 4/3 pi times radius cubed. So I'm going to take 4/3 times my 3.14 for pi times my radius 2.1 cubed. Go ahead and simplify my cube. It's 9 2600ths. Multiply across, and I would get 38 8/10. And it's centimeters cubed. Here they had a diameter of 7, and we need a radius for our formula, so we know that the radius is half of the diameter. So if you take 7 divided by 2, you get 3.5. And so we add that in here, and we would get our volume of 179 6/10 cubic centimeters. Now it's our turn. Alright, so we're going to find the volume of these spheres, and this one is talking about a radius of 10 centimeters. So we're going to take our formula, and we're going to replace the radius with 10. We're going to replace pi with 3.14, and we're going to multiply all of that by 4/3. So I happen to know that 10 cubed is 1,000. I can multiply these two, and I'm going to get 3,140 times 4/3. And then when I'm multiplying these, I'm just going to make it look like a fraction so I can multiply straight across. 3 times 1 is 3. 4 times 3,140 is 12,560. And I'm going to divide that by 3. And that is going to give me 4,186 and 7/10. So we are going to have 4,186 and 7/10 centimeters cubed. Okay. Sphere has a diameter of 3 4/10 meters. So we know that it has a diameter, so we know we have to find our radius. And that's 1.7. So we're going to plug that into our formula. We're going to use 3.14 for pi times 1.7 cubed. Multiply all that together, and I get 20 6/10 cubic meters. Okay, finding the volume of a sphere in a real-world context. Soccer balls come in several different sizes. One soccer ball has a diameter of 22 centimeters. What is the volume of this soccer ball? Round the answer to the nearest tenth and use 3.14 for pi. So we know the diameter. The diameter is 22 inches, or centimeters. So we need to find the radius. Half of 22 is 11. So 11 centimeters is going to be our radius. Plug that into our formula, replacing pi with 3.14 and replacing our radius with 11. We're going to cube our 11, and that we get 1,331. Multiply all of this together, divide by 3, and we get 5,572 and 0.4533. And we got to round it to nearest tenth. That 5 tells the 4 it's going to move up. So we get 5,572 and 5/10 cubic centimeters. If I were to find the volume of this ball, it's a 12-inch diameter, how many cubic inches of air does this ball hold? Round it to the nearest tenth and use 3.14 for pi. And I'd like for you to go ahead and do that now. So I cubed 6 and multiplied it by 3.14, then multiplied that by 4 and divided by 3. I got 904 and 32 hundredths. I need to round to the nearest tenth. So that means that my answer is going to be 904 and 3/10 cubic inches. Okay, the eggs of birds and other animals come in many different shapes and sizes. Eggs often have a shape that is nearly spherical. When this is true, you can use the formula for a sphere to find their volume. Because they're not exactly spherical, it's only going to come close. So if I have green turtle eggs that are approximately spherical with an average diameter of 4.5 centimeters, each turtle lays an average of 113 eggs at one time. Find the total volume of all the eggs to the nearest cubic centimeters. So the first thing we got to do is to find the volume of one egg. Okay, so we know it's pretty spherical, so we're going to use this. We're going to use 3.14 for pi, and we're going to find the radius. So we have our diameter is 4.5, and our radius is 2.25. So we have 2.25 cubed. So if I take 2.25 cubed times 3.14 times 4, and then divide that all by 3, I get 47,68875. I'm going to round to nearest tenth, and I get 47 7/10 of a cubic centimeter. That's for one egg. If I have 113 eggs, 113 of these, so I'm going to multiply 47 7/10 by 113, and that'll give me the total volume of all the eggs in that nest. And I got 5,390 and 1/10. So that means the total volume of all the eggs in the nest is 5,390 and 1/10 cubic centimeters. If you have any questions, please make sure you see your teacher.